Hi everyone, Assalamualaikum. In this video, we are going to continue with Series 2, a virtual workshop for final exam preparation, Calculus 2 for Engineers, MAT235. Hope you enjoy this video. Now we go to another segment, which is sample of final exam paper, right? Alright, from this sample of final exam papers, we have 3 printed pages, okay? And then we have 5 major questions. Question 1, 2, 3, 4, and 5, okay? And the total marks equals to 100 marks. And the percentage equals to 60%, okay? And then all these questions you need to answer within 3 hours time, okay? And another 30 minutes you use to scan and upload your answer, right? Next, we look at the sample of solution. We continue with question 2a. Question 2a. Given the function z equals to x plus y over x minus y, show that z(x) minus y zyy equals to 0, 7 marks, right? Now we look at the solution. Alright, to show that z(x) minus y zyy equals to 0, first we need to find zx, okay? To find zx, we differentiate from z equals to x plus y over x minus y. Okay, zx means we differentiate z with respect to x. Okay, we treat x as a variable and at the same time we treat y as a constant. Right? Right, let's say our x now equals to variable, okay, and then let's say y now equals to 2, okay, because now we treat y as a constant, okay. If we have z equals to x plus 2 over x minus 2, to differentiate z with respect to x, we need to use quotient rule. Before that, we need to identify u and v, okay. Our u equals to numerator x plus 2 and v equals to denominator x minus 2. Then we differentiate. Okay, we differentiate x equals to 1. We differentiate constant equals to 0. So our u prime equals to 1. Okay. And then when we differentiate v, we have v prime. We differentiate x with respect to x equals to 1. Differentiate constant negative 2, we have minus 0 here. Okay, and after we simplify, we have v prime equals to 1. Alright, we treat y as a constant. Okay, alright, so to find zx for z equals to x plus y over x minus y, we use the same technique. Okay, we use quotient rule. Okay, zx equals to vu prime minus uv prime over v squared. Okay, this is quotient rule formula. Okay, before that, we need to find u and v, and then find u prime and v prime. Okay, from here, our u equals to numerator x plus y. And v equals to denominator x minus y. Then we differentiate. Okay, we differentiate u, so the symbol become u prime. Okay, remember when we find zx, we treat x as a variable, and at the same time we treat y as a constant. Alright, so since x is a variable, so when we differentiate x with respect to x, the answer equals to 1. And since y, we treat as a constant, so when we differentiate any constant, the answer equals to 0, right? And then after we simplify, we have u prime equals to 1, okay? And then our v equals to denominator x minus y, okay? To find zx, okay, we treat x as a variable, and at the same time, we treat y as a constant. So, when we differentiate variable x with respect to x, the answer equals to 1. And when we differentiate y, the answer equals to 0. Y equals to 0, not dy over dx, because y now is not a variable, but we treat as a constant. So, when we differentiate any constant, the answer equals to 0. Then, after we simplify, we have v prime equals to 1. Then, we substitute into quotient rule formula. Okay? The symbol here is zx because we differentiate z with respect to x. Okay? Zx means we differentiate z with respect to x, we treat x as a variable, and at the same time, we treat y as a constant. Alright? Alright, from this formula, after we substitute v times u prime, so we get this, okay? X minus y times 1, okay? No need to write times 1 here, okay? And then in between is minus, and then u times v prime. So x plus y times 1, alright? No need to write times 1, okay? Because it doesn't change the original function, okay? And then over v squared, our v equals to x minus y, and then we have squared here, okay? From numerator here, we need to expand and simplify, okay? So we have zx equals to x minus y. After we expand negative with the function in bracket, so we have minus x, and then minus y. Okay, then after we simplify, so we have zx equals to x minus x equals to 0, minus y equals to negative 2y, and then over x minus y bracket squared. Okay, no need to expand the denominator. Okay, alright, from zx equals to negative 2y over x minus y squared, okay, we also can write zx equals to negative y bracket x minus y to the power of negative 2, right? So this is our zx, right? After we find zx, okay, we need to find zy, right? To find zy, from z equals to x plus y over x minus y, we differentiate with respect to y. What is zy? Okay, zy means we differentiate z with respect to y, we treat y as a variable, and at the same time, we treat x as a constant. Okay? Right, let's say we consider our z equals to 1 plus y over 1 minus y. Okay, let's say our x equals to constant and y is a variable. Okay, so from here to differentiate z, we need to use quotient rule. Okay, and when we use quotient rule, we need to identify u and v. Okay, so in this case, our u equals to 1 plus y and v equals to denominator 1 minus y. Then we differentiate. Okay, we differentiate u, we have u prime. Differentiate any constant equals to 0. Differentiate y with respect to y equals to 1. And then after we simplify, we have u prime equals to 1. Right? And then we need to differentiate v equals to 1 minus y. We differentiate v, the symbol become v prime equals to, differentiate any constant equals to 0, differentiate y with respect to y, the answer equals to 1. So we have 0 minus 1 equals to negative 1, right? Okay, we recall back, if our z equals to 1 plus y over 1 minus y, we treat x as a constant, let's say x equals to constant 1. So to differentiate z with respect to y, which is zy, we need to use quotient rule. And when we use quotient rule, we need to define u and v. And then find u prime and v prime, right? Alright, so same goes to if z equals to x plus y over x minus y, and we treat x as a constant. Okay, so using quotient rule formula, zy equals to vu prime minus uv prime over v squared. Okay, so from here our u equals to x plus y and v equals to x minus y. Remember, when we find zy, we treat x as a constant. Let's say constant 1. Okay, so we differentiate any constant, the answer equals to 0. And differentiate y with respect to y equals to 1. And after we simplify, u prime equals to 1. Alright, and then v equals to x minus 1. Sorry, x minus y. So when we differentiate v, we have v prime equals to, we differentiate x equals to 0. Why 0? Why not equals to 1? Because when we find zy means we treat x as a constant. And when we differentiate any constant, the answer equals to 0. Okay, when we differentiate y with respect to y, the answer equals to 1. Right? And then after we simplify, v prime equals to 0 minus 1 equals to negative 1. Yeah, then we substitute into quotient rule formula to find zy. Right? Right, so our zy equals to vu prime. So x minus y times 1. Okay, times 1, no need to write. And then in between is minus. And then u times v prime, okay, or v prime times u. So we have negative 1 times x plus 1. And then over v squared, v equals to x minus y. And then bracket squared, okay. Then we have negative sign here and then times negative 1. So we have zy equals to x minus y. Okay, this sign now equals to positive sign. Okay, and then x plus y. Okay, when we multiply by positive sign, the sign from x plus y here doesn't change, right? So after we simplify, y minus y equals to 0, x plus x equals to 2x. Okay, so our zy equals to 2x over x minus y bracket squared. Okay, we just expand and simplify the numerator. Okay, no need to expand the denominator. Alright, or we can write zy equals to 2x. We move bracket squared to numerator here and we get bracket x minus y to the power of negative 2 using the properties of indices. Alright, so this is our zx. Okay, we differentiate z with respect to x, and this is our zy. We differentiate z with respect to y. Right? From the previous slide, we done find zx. Okay, this is our zx from the previous slide. Okay, and we done find zy. This is our zy from the previous slide. Right? Now we want to find z as x. What is z as x? Z as x is we differentiate zx with respect to x. Okay, we treat x as a variable and at the same time we treat y as a constant. Okay, right. To explain z as x, okay, let's say first we assume our zx equals to negative 2 times 2. Okay, we assume y as a constant where y, let's say, equals to 2. Okay, we just assume. Okay, and then times x minus 2. Okay, we assume y equals to constant 2. And then bracket to the power of negative 2. So now our zx equals to negative 2 times 2 equals to negative 4. And then bracket x minus 2 to the power of negative 2. So when we differentiate zx with respect to x, so we have zxx. Okay, how to differentiate zx with respect to x? Okay, since we have multiplication between constant and bracket to the power of any constant, so we can differentiate using generalized power rule. Right? When we use generalized power rule, we need to multiply power here and the constant in front here. Okay, so we have negative 2 times negative 4 equals to 8. Okay, and then we just copy the function in bracket and then power minus 1, so negative 2 minus 1 equals to negative 3. And then don't forget to multiply by the derivative of the function in bracket. Okay, so we differentiate x. Now we treat x as a variable, so equals to 1. And then we differentiate constant equals to 0. Okay, so we have 1 minus 0 here. Right? So now we go back to zx equals to negative 2y bracket x minus y to the power of negative 2. Okay. Using this technique, okay, after we differentiate zx with respect to x, the symbol becomes zxx. Okay. So using this technique, we multiply negative 2 and negative 4 here, so we get positive 8. So using the same technique, we multiply negative 2 and negative 2y. So we have 4y. Remember, y now we assume as a constant. Okay? Because we want to find zxx. Zxx means we differentiate zx with respect to x. Okay? We assume y as a constant. Right? And then after we multiply this, okay, we copy the function in bracket like this, okay, and then to the power of negative 3 because negative 2 minus 1. And after that, don't forget to multiply by the derivative of the function in bracket. Okay, in bracket we have variable x. After we differentiate with respect to x, so we get 1 and then minus y. Now we treat as a constant, so we differentiate any constant, the answer equals to 0. So we have 1 minus 0 here. Okay, and 1 minus 0 equals to 1. 1 times 4y equals to 4y. Okay, so we have zxx equals to 4y bracket x minus y to the power of negative 3. Alright? Alright. We recall back from the given question. Show that x, z, z. Okay? Now we have z as x. Okay? So from here, to find x, z as x, we need to multiply z as x here by x. Okay, so after we multiply both sides by x, so we have x z equals to 4xy and then bracket x minus y to the power of negative 3. Yeah, this is our x z. right? After we find x, z as x, now we want to find y, z, y, y. But before that, we need to find z, y, y. Alright? What is z, y, y? Z, y, y means we differentiate z, y from here with respect to y. Okay, we treat y as a variable, and at the same time, we treat x as a constant. Alright? To explain how to find z, y, y, okay, we differentiate from here. Let's say we assume our x now equals to 1, okay, because x is a constant. So let's say we replace x equals to 1 in zy. Okay, so we have zy equals to 2 times constant 1, okay, and then times in bracket constant 1 minus y, and then close bracket to the power of negative 2. Right? And after we simplify, so we have zy equals to 2 times 1 minus y bracket to the power of negative 2. Alright? When we differentiate zy with respect to y, we can differentiate using generalized power rule because we have multiplication with the constant in front here. Okay? So using generalized power rule, we multiply power and the constant in front here. So we have negative 4. And then we just copy the function in bracket, 1 minus y. And then to the power of the original power minus 1. So it is equals to negative 2 minus 1 equals to negative 3. And then we need to multiply by the derivative of the function in this bracket. Okay, differentiate 1 equals to 0, and then minus differentiate y with respect to y equals to dy over dy, which is equals to 1. Right? Next, to find zyy, from here, we use the same technique. Okay? So from here, we just differentiate zy with respect to y. So we get zyy equals to, we multiply negative 2 with 2x here. Remember, x now we treat as a constant. So we just multiply the power and the constant in front here. Okay, so after we multiply negative 2 and 2x, so we get negative 4x. Okay, after that, we just copy the function in bracket. So we have x minus y, and then to the power of negative 3. Okay, and after that, we need to differentiate the function in bracket. Okay, in bracket, we have x minus y. When we differentiate x, where we treat x as a constant, so we get 0 here, and then minus differentiate y, where y is a variable, with respect to y equals to dy over dy, which is equals to 1. Okay, and then after we simplify, so we have zyy equals to, this is negative 1 times negative 4x, so we have positive 4x, and then bracket x minus y to the power of negative 3, right? After we find zyy, now we can find yzyy, okay? From here, we just multiplying by y for both sides, okay? So we get zyy equals to 4xy times x minus y bracket to the power of negative 3, right? So we done find x z as x and y z y, right? Alright, after that, we refer from the given question here, show that x, z, xx minus yzyy equals to 0. So we use the term from left-hand side here. Okay, we have x zxx minus y zyy equals to, we replace x zxx equals to 4xy times x minus y bracket to the power of negative 3, and then minus, okay, yzyy. Okay, we replace yzyy equals to 4xy bracket x minus y to the power of negative 3. From here, you can see that we want to subtract with the same term. Okay, so we can simplify both terms. Okay, so we get x zxx minus y zyy equals to 0. Okay, then we compare from here. Okay, it is the same. Okay, means that we done show that x zxx minus y zyy equals to 0. So we can write shown here. Right? Got it? Next, we continue with question 2b. Question 2b. This is the given question. Okay. Now we look at the solution. Okay. We check one by one. The radius r and the height h of a right circular cone are decreasing at the rates of 4 cm per min and 3 cm per min respectively. Use the chain rule to find the rate at which the volume is changing at the time when r equals to 15 cm and h equals to 20 cm. 7 marks. Okay. Right, we have radius r. And then the word decreasing. Okay. 4 cm per min. Okay. Using partial derivative, we can write del r over del t equals to negative 4 cm per min. Why negative? Because the word here is decreasing. Right? So, from here, we can put the symbol del r over del t. Okay, why over del t or time? Because from the given unit here, we have minutes. Okay, minutes means the unit for time. Right? After that, height h decreasing and then 3 cm per min. Okay, so we can write del h over del t equals to negative 3 cm per min. Right? And the word here is decreasing. So we put negative symbol here. Right? Use the chain rule to find the rate at which the volume is changing. Okay? So we can use the symbol dv over d time equals to question mark. Okay? Because we want to find. Okay? When r equals to 15 cm and h equals to 20 cm. Right? After we extract all the information and we write in terms of mathematical symbol, so we can start with volume of cone equals to 1 over 3 pi r squared h. From this formula, we have two variables, which is r and h. Okay, so we can differentiate using partial derivative with respect to r and with respect to h. Okay. When we differentiate with respect to r, so we treat r as a variable. Okay, and at the same time we treat h as a constant. Okay, since now we treat h as a constant, so I put h beside all these constant. Okay, so it is easy to differentiate and we can avoid error. Okay, so from here, after we differentiate partial derivative v, with respect to r. So we get del v over del r equals to, we still have constant 1 over 3 pi h, okay, and then we just differentiate r squared, okay, which is equals to 2r, okay. Alright, you just imagine, let's say you want to differentiate constant 4r squared, so the answer equals to 8r. Why? Because we just put constant 4 in front and then we differentiate r squared, so we get 2r. That's why after we simplify, we have 8r. Okay, so same goes to this function. Alright? Right, so after that, we simplify, so we have del v over del r equals to 2 over 3 pi r h. Right? After that, we replace r equals to 15 and we replace h equals to 20. Okay, then we solve, so we have del v over del r equals to 200 pi. Right? Now we want to differentiate volume with respect to h. Okay, means that we treat h as a variable. Okay, so we have volume equals to 1 over 3 pi r squared h. Okay, now we treat h as a variable and we treat r as a constant. So all of this now is a constant. Okay, so to differentiate v with respect to h using partial derivative, so we have del v over del h equals to, we just write this constant 1 over 3 pi r squared and then we differentiate h with respect to h equals to 1. Okay, to explain why we get this, okay, let's say all these constant, let's say we assume equals to 5h. Okay, when we differentiate 5h with respect to h, we will get 5. Why? Because we just copy constant 5 in front and then we differentiate h equals to 1. So after we simplify, the answer equals to 5. Right? But now we have constant in terms of this symbol. Okay, 1 over 3 pi r squared. Okay, we just put all the constant in front here and then we differentiate h with respect to h equals to 1. Okay, then we simplify, so we still have 1 over 3 pi r squared. Okay, this is our del v over del h. Okay, then we replace r equals to 15. Okay, from here there is no h. Okay, so no need to replace h. Okay, we just replace 15, okay, into r here. Okay, then we solve, so we have del v over del h equals to 75 pi. Right? After we find del v over del r and del v over del h using partial derivative, so we can find dv over dt using chain rule, right? Using chain rule, we can write dv over dt equals to, since we have two variables here, so we need to write del v over del r times del r over del t, okay? The derivative containing variable r, and then we put plus here, and then del v over del h times del h over del t. Okay, we write in terms of variable h. Alright. Let's say if we imagine we simplify this and this. Okay, we will get del v over del t. Okay. Alright. So from here, before that, this is called chain rule, right? Alright, from here we just substitute. Okay, one by one. Okay, we have dv over dt equals to del v over del r from here equals to 200 pi. And then times del r over del t from here, okay, equals to -4. And then plus del v over del h from here equals to 75 pi. And then times del h over del t from here equals to -3, right? And after that, we can solve this. So we have dv over dt equals to -1025 pi. Okay? And after that, from v and t here, we can put a suitable unit. Okay? The unit is, for volume, we can write cm cube. Okay? Why cm? Because the given unit for del r over del t and del h over del t is equals to cm over mean. Okay? So when we find dv over dt, the unit is cm cube for volume and then over minute for time. Okay, so this is the final answer. Okay, for dv over dt. Okay, dv over dt means the rate at which the volume is changing. Right? Got it? Madam, boleh kita rehat sebentar? Baiklah anak-anak, kita take file dulu. Kita sambung lepas ni ya. Coming up next, sample of final exam paper MAT235 Calculus 2 for Engineers, ODL. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.